Your cat is staring at you from across a dark room. You can't see its body. You can't see the chair it's sitting on. But those two glowing orbs, crystal clear, no flashlight, no filter, no explanation. Just your cat, apparently running its own internal lighting system from across the hallway. And here's where most people make the same mistake. They assume those eyes are doing something, producing something, like the cat is somehow generating that glow from the inside. But you've probably called it creepy at least once. Maybe you've seen it in a photo and thought the camera glitched. Horror movies have been using it for decades precisely because it feels wrong, feels alien, feels like something no normal animal should be able to do. But here's the thing, your cat isn't producing a single photon of that light, it's recycling yours. And the mechanism it uses to do that is one of the most elegant pieces of biological engineering in the animal kingdom. Sitting quietly behind the part of the eye you actually know about, doing a job humans gave up on a very long time ago. And before we even get into the anatomy, let's sit with that for a second. Because most of the things that feel supernatural about animals have explanations that are somehow more impressive than the supernatural version. The glow feels like magic because we assume that light has to come from somewhere, that something has to be generating it. We live in a world where glow means power source, LED, flame, screen. We've trained ourselves to look for the origin of the light. So when something glows and there's no obvious source, the brain reaches for the closest explanation it has, which is usually something like bioluminescence or electricity or just plain wrongness. But this isn't bioluminescence. Deep-sea fish do bioluminescence. They actually manufacture light using chemical reactions in their bodies. Your cat is doing something entirely different and arguably more sophisticated. It's not making anything. It's catching what already exists and refusing to waste it. So let's start with what you actually see, described plainly. You're in a dim room, a car hits your cat with headlights for half a second, and two bright points of reflected light fire back at you. That's the core of it. Each light goes in, bounces back out. Simple. Except it isn't because your eyes are also hit by those same headlights and they don't fire anything back. You get nothing. Your eyes just absorb the light and move on. So why does your cat's eye send it back out like a signal flare? The answer is a layer of tissue sitting directly behind the retina. A structure called the tapetum lucidum. Most people have never heard of it, and that's exactly why the glow feels mysterious. The name sounds like a spell, but the logic is embarrassingly simple. Think about reading a book in a dim room. You can barely make out the words because there isn't enough light. Now imagine sliding a mirror behind the page so every beam of light that passes through hits the words once on the way in, then bounces back and hits them a second time on the way out. Suddenly, you're getting twice the use out of the same light. That's the tapetum. It's a biological mirror sitting behind the retina. Haas catching every photon the retina didn't absorb on the first pass and flinging it right back through for a second attempt. The glow you see isn't the cat showing off. It's the leftover light escaping back out of the eye after that second bounce, and you just happen to be standing in the right angle to catch it. Now here's the part that gets interesting. That glow isn't always the same color. Your cat might shine green. A dog might go gold. A crocodile hits you with a deep amber. So that variation comes down to the specific composition of the tapetum in each species. Different cells, different pigments, different angles of reflection. And even within cats, age and individual pigmentation shift the color. So there's no single cat glow. It's a spectrum, and it changes depending on exactly what you're looking at and how. And here's something most people never think to ask. Why does the glow seem to disappear when you shine a bright light directly at a cat? Because the tapetum only has leftover light to reflect when the retina is working hard to absorb everything it can. Flood the eye with too much light and the retina handles it all. Nothing reaches the mirror. Nothing bounces back. The glow doesn't vanish because the cat turned it off. It vanishes because there's nothing left to recycle. That's how precisely tuned this system is. There's another detail worth pausing on here, one that most explanations skip entirely. The tapetum doesn't just reflect light. It reflects it in a very specific direction. It's not a random scatter, not a diffuse glow spreading out in all directions like a lantern. It's closer to a retroreflector, bouncing the light back along roughly the same path it came in on, which is exactly why you only see the eye shine when you're roughly in line with the light source. Stand to the side and you'll miss it completely. The cat's eyes aren't broadcasting the glow outward to everyone in the room. They're sending it back to you specifically, because you're the one who sent the light in the first place. It's almost like the eye is returning your call. That precision matters, because it also tells you something about the structure of the tapetum itself. It has to be angled and layered carefully enough to pull that off. This isn't just a flat mirror bolted behind the retina. In many species, it's a stack of crystalline plates arranged with incredible regularity, thin enough that light waves interfere with each other as they bounce between layers. That interference is partly what produces those vivid, saturated colors. It's structural color, the same physics that makes a butterfly wing iridescent, happening inside your cat's eye. But here's the contrast worth making, because people confuse two different things constantly. When the glow in a cat's eyes is not the same as red eye in your own photos. When a camera flash hits your eyes and you come out looking demonic in the picture, that's also a reflection. But it's bouncing off the blood vessels lining the back of your retina, which is why it's red. Blood red, specifically. You have no tapetum, no mirror, just a vascular surface that happens to reflect light at the wrong moment. Similar visual effect, completely different anatomy, completely different reason. One is a precision-engineered night vision upgrade. The other is basically a plumbing accident caught on camera. So, where did the tapetum come from and why? Picture something small and cat-like, moving through dense forest about 50 million years ago, in that thin slice of time just after sunset when the light is nearly gone but prey animals are still moving, still exposed, still catchable, if you can see them. Most predators at that hour are effectively blind, but not this one. Because behind its retina, light is bouncing twice. Moonlight, starlight, whatever weak ambient glow exists, it's all being recycled into usable signal. That's not a quirk. That's an edge. That's the difference between eating and not eating. And what's remarkable is that nature didn't invent this trick once and share it around. One theory, widely accepted among researchers, is that the tapetum evolved independently in multiple lineages. Sharks developed their own version, deer have one, dogs have one, crocodiles have one. Nature kept arriving at the same solution because the problem, how do you see when there's almost no light, kept coming up over and over across completely different animals. The mirror answer kept winning. It's worth pausing on how unusual that is. In evolutionary biology, when two unrelated species arrive at the same solution independently, it's called convergent evolution. And it's one of the more fascinating patterns in all of biology because it suggests that some solutions aren't just good, they're almost inevitable. Wings evolved separately in birds, bats, and insects. Streamlined body shapes for moving through water appeared in fish, dolphins, and extinct ichthyosaurs. Camera-style eyes, a lens focusing light onto a sensitive surface, evolved independently somewhere between 4 and 40 times depending on how you count. The tapetum fits that same pattern. It's not a feature that got passed down from a single ancestor. Different animals ran the same calculation. More light sensitivity at night equals better survival. And nature kept landing on the mirror as the answer. That kind of convergence is almost an argument, made in flesh and time, that the mirror design is genuinely optimal for the problem. And once you know it exists, you start seeing it everywhere. Your cat on the couch at 2 a.m., eyes suddenly lit up when you walk past. Deer locked in your headlights on a country road, that brief flash before they bolt. Your dog in a flash photo with that slightly eerie greenish shine that always looks a little off. Raccoons rifling through your trash at midnight, two small lights moving around in the dark. Sharks in nature documentaries, that cold, flat silver stare that makes the footage feel genuinely threatening. Horses in an unlit stable. Even the phrase, eyes like a cat, which people use to mean someone who seems to catch everything, notice everything, see in the dark where others are blind. That phrase exists because humans have been watching this effect for thousands of years and intuiting, correctly, that something different is happening inside those eyes. The trade-off, though, is real, and it's worth knowing. The mirror scatters light slightly. It's not a perfect system. Neat cats don't see as sharply as you do in full daylight. Their visual acuity is lower, their color range is narrower, and the crispness of detail that you get in bright conditions is something they simply trade away in exchange for sensitivity in the dark. It depends on the animal and the conditions, but broadly speaking, The tapetum is a night mode optimization, and night mode always costs something in the daylight. Think of it like a camera sensor. So you boost the ISO and you get more sensitivity in low light. But you also get noise, grain, a loss of fine detail. The cat's eye is running on permanently high ISO. Great for the hallway at midnight, less great for reading fine print. Their world is brighter in the dark and slightly softer everywhere else. And for a hunter that does most of its serious work in the hours around dawn and dusk, that's exactly the trade you'd want to make. It's also worth knowing that not every nocturnal animal uses this solution. Owls, for example, have no tapetum at all. Instead, they evolved enormous eyes that simply collect more raw light from the start. A completely different answer to the same problem. An owl's eye is so large relative to its skull that the eye can't actually move in the socket. That's why owls rotate their heads so dramatically, up to 270 degrees, instead of just glancing sideways. They solved the night vision problem by going bigger, by building a larger aperture that catches more photons before they even reach the retina. No recycling needed, just a bigger bucket. Which tells you something important. There's rarely one way to solve a hard problem in nature. There are just different bets, different trade-offs, different designs that worked well enough to survive. So the next time those two glowing orbs stare back at you from across a dark room, that's not creepy. That's a biological mirror doing its job. You gave up night vision for sharper daylight. Your cat kept the mirror and owns the dark.